To draw the lowest structure for selenium dichloride, I first am going to go through and do the inventory. There's 1 selenium and 2 chlorines. Each selenium contributes 6 valence electrons, whereas each chlorine contributes 7. I'm multiplying across and adding to get a total of 20. Selenium is placed as the central atom. The 2 chlorines are placed around it, and I'm connecting each chlorine to selenium using a single bond. I use up 4 valence electrons to do that. Now I have 16 left over. Now I'm going to fill the shells of the outer elements. As I'm adding electrons into the structure, I'm making sure to subtract from the inventory. So I fill that first chlorine, I now have 10 electrons left over. I fill that second one, and now I have 4 left over. So I'm going to place those 4 remaining electrons on the central atom as 2 non-bonding pairs. Now I've used up all of my electrons. When I check selenium, it has 2, 4, 6, 8 valence electrons. So this one follows the octet rule. That central atom has 8 valence electrons total. There's 8 non-bonding pairs, 2 bonding pairs. 8 plus 2 gives me 10, times 2 gives me 20. That's how many valence electrons I wanted in this structure. To draw the lowest structure for chlorine trifluoride, my first step is going to be to create the inventory. So I have chlorine and fluorine. There's 1 chlorine, there's 3 fluorines. Both chlorine and fluorine contribute 7 valence electrons. I multiply across and add to get a total of 28. Chlorine is placed in the center, the 3 fluorines around it. Each fluorine is going to be connected to chlorine using a single bond. That uses up 6 of my electrons, leaving me with 22 left over at this point. I'm now going to fill the shells of the outer atoms, and as I fill each shell, I'm subtracting from my inventory. So now I have a total of 4 electrons left over. I'm going to place those 4 remaining electrons as non-bonding pairs on that central atom. So I'm going to place 2 non-bonding pairs on that central atom. I'm making sure it's very clear that there are 2 separate non-bonding pairs on that central atom. Now I've used up all of my electrons. When I check that central atom, it is 2, 4, 6, 8, 10 electrons. It doesn't follow the octet rule. It ends up being an expanded octet. I expanded that octet by simply following the normal steps. All right, so I have a total of 11 non-bonding pairs and 3 bonding pairs. 11 plus 3 gives me 14, times 2 gives me a total of 28. That's how many valence electrons I wanted in the structure. To draw the lowest structure for tetrachloroiodide, I'm first going to do my inventory. I have 1 iodine and 4 chlorines. Each iodine contributes 7 valence electrons, and each chlorine also contributes 7 as well. I'm multiplying across and adding to get a total of 35. Since it has a charge, I need to factor in that charge to the inventory. I'm going to do the opposite of whatever the charge is, so I'm going to add 1 to give me a total of 36. Iodine is placed as the central atom. The 4 chlorines are placed around it. Each chlorine is connected to iodine using a single bond. That uses up 8 electrons total, leaving me with 28. I'm now going to go through and fill the shells of the outer elements. As I'm doing that, I'm subtracting from the inventory. And you could see when I finally fill that last chlorine's outer shell, I'm now going to be left with 4 valence electrons. I need to place those 4 valence electrons on that central atom as non-bonding pairs. So I'm going to clearly add 2 non-bonding pairs onto that central atom, and now I have 0 left over. So when I check that central atom, it has 2, 4, 6, 8, 10, 12. It has 12 valence electrons. That means it's an expanded octet. I just need to make sure, since it's charged, I'm putting brackets around it with that charge in that upper right-hand corner. There's 14 non-bonding pairs and 4 bonding pairs. 14 plus 4 gives me 18, times 2 gives me 36. It matches how many valence electrons I wanted in the inventory. To draw the lowest structure for phosphorus tribromide, the first thing I'm going to do is the inventory. There's 1 phosphorus and 3 bromines. Each phosphorus contributes 5 valence electrons. Each bromine contributes 7. I'm multiplying across and adding to get a total of 26. I place phosphorus in the center. I place the 3 bromines around it. I'm connecting each bromine to phosphorus using a single bond. That uses up 6 valence electrons total, leaving me with 20 at this point. I then go through and fill the shells of the outer atoms. As I'm filling those shells, I'm subtracting from the inventory. And when I fill that last bromine, I now have 2 electrons left over. So I'm going to place those 2 electrons on that central atom, and now I reach 0. So now when I check that central atom, it has 2, 4, 6, 8 valence electrons. This structure follows the octet rule. It's done. Non-bonding pairs is 10, bonding pairs is 3. 10 plus 3 gives me 13, times 2 gives me 26. It matches how many I wanted in the Lewis structure. To draw the Lewis structure for ammonium, I'm going to start off with the inventory. There's 1 nitrogen and 4 hydrogens. Each nitrogen contributes 5 valence electrons, whereas each hydrogen contributes 1. I'm multiplying across and adding to get a total of 9. But I need to factor in that charge, so since it's plus 1, I'm going to subtract 1 to give me a total of 8. Nitrogen's my central atom. I place the 4 hydrogens around it. I'm connecting each hydrogen to nitrogen using a single bond. That uses up 8 electrons, and now I'm left with 0. When I check that central atom, nitrogen has 2, 4, 6, 8 valence electrons. Therefore, it follows the octet rule, and it's done. I just need to place the brackets with the charge in the upper right-hand corner. There's 0 non-bonding pairs, 4 bonding pairs. 0 plus 4 gives me 4, times 2 gives me 8. That's how many valence electrons I wanted in this structure. To draw the structure for arsenic pentafluoride, I'm first going to go through and do the inventory. There's 1 arsenic, there's 5 fluorines. Each arsenic contributes 5 valence electrons, whereas each fluorine contributes 7. I'm multiplying across and adding to get a total of 40. I'm placing arsenic in the center. I'm placing the 5 fluorines around it. I'm connecting each fluorine to the central atom using a single covalent bond. That uses up 10 of my electrons to leave me with 30 at this point. I'm then going to go through and fill the outer shells. As I fill each outer shell, I'm subtracting from the inventory. And what I'm eventually going to see once I fill that last shell is that I have 0 electrons left over. When I check that central atom, there's 10 valence electrons. It's not following the octet rule, it's an expanded octet. There's 15 non-bonding pairs, 5 bonding pairs. 15 plus 5 gives me a total of 20, times 2 gives me 40. That's how many valence electrons I wanted in the Lewis structure. To solve the Lewis structure for bromine pentafluoride, I'm first going to go through and do the inventory. There's 1 bromine and 5 fluorines. Each bromine contributes 7 valence electrons, each fluorine contributes 7. I multiply across and then add to get a total of 42. I place bromine as my central atom. I place the 5 fluorines around it. I connect each fluorine to bromine with a single covalent bond. That uses up 10 electrons. Now I have 32 left over. Now I'm going to go through and fill the shells of the outer elements. And as I'm filling those shells, I'm making sure to subtract from my inventory, and eventually I fill that last fluorine and I have 2 electrons left over. I'm going to place those 2 electrons on that central atom as a single non-bonding pair, and now I've used up all of the electrons. When I check bromine, there's 2, 4, 6, 8, 10, 12 valence electrons. This is an expanded octet, so I'm done. There's 16 non-bonding pairs and 5 bonding pairs. 16 plus 5 gives me 21, times 2 gives me 42. That's how many valence electrons I needed in the structure. To draw the Lewis structure for xenon dichloride, my first step is to do the inventory. There's 1 xenon and 2 chlorines. Each xenon contributes 8 valence electrons, each chlorine contributes 7. I multiply across and add to get a total of 22 valence electrons. Xenon is the central atom. I place the 2 chlorines around it. I'm connecting each chlorine to xenon using a single covalent bond. That uses up 4 valence electrons total. Now I have 18 left over at this point. I'm going to go through and fill the shells of those outer elements. And now I have 6 valence electrons left over. So I'm going to place those 6 valence electrons on the central atom as 3 non-bonding pairs. And I'm making sure that it's very clear that there's 3 separate non-bonding pairs on that central atom. I've now used up all of my electrons, and when I check xenon, there's 2, 4, 6, 8, 10 electrons. It's an expanded octet. So there's 9 non-bonding pairs, there's 2 bonding pairs, so 11 times 2 gives me 22. That's how many valence electrons I wanted in the structure.